everybody. In this episode, we sprung a leak in our water bag and had to do some diagnostics there. And also, we overheated the motor. And I was trying to figure out, well, what is overheating exactly? So I went through a number of tests to sort that out. Was it the controller or was it the motor?
Oh my goodness. I caught one of those birds going out. Look at that. We're doing this motor test. It's been running for half an hour. 600 watts, what I'm pulling out of it. And I've got my temperature readings here. So I'm using a thermometer. And so I'm due here now for another one. So basically I'm just sort of going here along the top of the heatsink. It's saying what's the maximum temperature. So 96.2. And then down here, I'm checking this out. This is Celsius, by the way.
You have to let the liquid fall into your throat instead of actually drinking it.
38.3.
That's why you put your head up and use gravity.
So down here it's 38.
Like that drinking motion uses time and air.
And 96.2. And this is 222.
But it also feels like you're drowning yourself.
So you can see my chart here that I'm just basically keeping. So I'm just running this test here in the dock, tied up. And my theory was that while at the dock, because the boat's not moving, it's actually maximum resistance because we're not getting any slip. So I should be able to overheat the motor this way quicker than while I'm moving, because then if I run 600 watts, I think I'll be able to go quite a bit longer because the resistance of the boat lessens as it's moving, and the propeller's going through the water as opposed to trying to push the water. It's my theory, anyways. I don't know. Maybe there's some engineer out there who really understands fluid mechanics and could tell that to me in the comments. That would be great. And then, yeah, in the meantime, we're trying to waste our water. So then the other thing over here that we're just trying to get this thing down here, we're wasting our water, but this the bilge pump was starting to go off when we're filling up the water, and it seems like it's coming out of the black piece, the little elbow connector. So just checking that out now. So we're wasting some wire. I'm just going to take water. I'm just going to take it apart and then reseal it. So let's see how it goes. And it's a hot day today, 30 degrees. So hopefully we get these project's done because it's hot in here. So basically this thing was crooked on the connector, but I know that it was straight before, so I'm a little bit worried. Maybe it just got a bit loose, but it's nothing's damaged, and the little rubber ring is still in there. And I think that was all why this was leaking. There it goes. So because it was crooked, it was leaking right there on the top. You can see the water in there. So I think we'll be okay now. So do you want to start getting the water back in it?
Again?
Yeah, let's do another test, so fill her up. Discovered that at 100 degrees, the controller shuts off with a 11 beep alert. So I'm just going to look up what that is right now. Checking from the Golden Motor site, the error codes. So there's two of them to pay attention to for the overheating. One of them was 11, and that's the controller overheating, and the other one is 13, which is the motor overheating, and mine was beeping 11 times. So the controller cut out at basically 100 degrees. So you can see here in the temperature settings, I actually don't have a Celsius setting for the controller. The only temperature settings in the listing is actually the motor over temperature enable, motor current limit temperature, level 1 is 120, level 2 is 130, which is supposed to be limiting some current. Maximum motor protection is 150, and then the motor temperature exit value is 20. So that is in Celsius. I'm almost positive. So a little bit confused because in this listing there is no other temperature that I can find.
So down here are the controller settings. So regenerative braking, controller functions. So cruise control, forwards, 3 gears, boost, and speed throttle type. So I don't know how to set that. So I think I'm going to ask the question on the user form, but in the meantime, so this is why I got this thing here. This plate is basically a cooling plate, which I'm going to put some liquid through. That'll hopefully keep the controller under 100 degrees. And then this gets hot. Right now it's max 94.7. Max 75, 75, 75, 76. So right now it's 76 degrees, which is about where I was at the 20-minute mark. So it's taken about the same amount of time to cool as it is to heat. So I'm going to run this test again as soon as it gets down to 33, or ambient air temperature. It's 30 degrees here today. And then I'm going to run it with much more amps, and then I'm going to see how that works. Top there, big time. Look how the dripping down. Alright, we're going to have to take the water out and check this thing again. I don't know what's going on with this seal. So as you can see here, down at the bottom, I'm running 530 watts, 520 watts roughly for the motor. And so far what I found, just using my temperature sensor, so basically I'm just pulling this back. I put my Sietra fan there, and I'm just running a test here. So it's 54.7, 55, 54, 55, so 55.3. We'll go with that. And then I'm just trying to find out where that is roughly, so 55.3. And I'm not bothering to check the motor, I'm just putting the time here. So this is 4:31. So just at initial checking here, this is without the fan, this is with the fan. So it's going from 2, so it's already 10 minutes over a 3 or 4 minute time span. So I've easily doubled the running time just by having that fan in behind with just some air. And what I also found was that at 1800 watts it was keeping it cooler, so it got up to a certain temperature, but the fan was keeping it from bottoming it out. So really all I needed was a little bit of airflow over that thing, but it's still, that's 80 degrees Celsius, like that's damn hot. So it did cut out on me after it looks like about 11-12 minutes at 2000 watts. So that would be 2000 watts at 50 volts. Yeah, 50 volts, 2000 watts. I guess the volts doesn't really have anything to do with it, but it's the controller that's overheating, not the motor temperature. I stopped checking because it's the highest it ever got was 40 degrees, and it's supposed to be able to run up to 100 degrees. So the motor's never getting anywhere near that. It's just the temperature. So I'm debating what to do with the cooling, because I'm thinking maybe I'll put like a split system in, because I can have water go through the liquid cooled motor as well, but I think I'm artificially going to be heating the motor up by having the hot water from the controller go through it. So aside from just offering more capacity, it doesn't seem like that makes sense to do. So I'm going to install the liquid cooling and rerun these tests and see what difference it makes with the liquid cooling on. But for now, I'll keep running my test to see how far I get here. Still running at 500. It keeps creeping up for some reason. Now it's 580 watts. And I'll keep running that test until the temperature overheats, I guess. Or if it never does, it never does with this thing on. But I'm suspecting it's not going to overheat now. So I'm going to try one more thing. I'm going to take the bag right out, and I'm going to try to seat the connectors on there where they're flat. So that way I've got like a flat surface to try to screw them onto, because they're still leaking. So basically all the water is going into the bilge. So I'm going to take this out here now.
Then once you add water, does it need to be flipped? Yeah.
Okay. Well, I think I'm going to have to take these things out. and then dry them off. And then get a fan in here to dry out this whole container. Well, that's all the water from the tank here. I got the tank out. So I'm going to see how to fix these connectors on tightly somehow out here, and then slip the bag back in and see if I can make this watertight. What I discovered is that in here there's an O-ring, and this piece, if it's not exactly square, this nozzle, then it actually doesn't bite well on the outside edge. And then, so what I had to do was basically take everything all apart and then reseat it. But by holding this down while twisting that on my my knee, then what ended up happening is that I was able to stop the water from leaking. So I think it just got crooked somehow. Get this one on now. This time, when you slip it on, be very careful with the end. Perfect. Coming in here now, so we'll just check it out here in 20 minutes. I cut it coming in slow just so I don't have so much water. But just want to see if I get any leaks on top. I'm just checking here, but it doesn't seem like there's any leaks anywhere. Not yet. Everything's dry. I was wondering if the hose was twisted a bit at the top. It's not leaking now, and I think I've deduced what happened. So this connector becomes more rigid as the bag fills, and this hose does not turn. So when I installed it, I think I had the hose like turned this way more. And as the water fills in, the pressure on this wants to pull the cap to the left because the hose doesn't have as much give as the bag. So I think it just popped the thing off, and then it started to leak. So once I got it in there straight and I clamped it down, it's not leaking again. So I think what I did here is I just took the drill and I loosened up the clamps, these two clamps. And it's more, now there's no pressure trying to turn it when it's full. So I think that's actually what happened. But this is pretty full now. David, it's full! 12. So it took 12 minutes at a very slow trickle rate to fill the tank here. 150 liters. So yeah, it's not leaking. So I'm just going to raise up my sail because it got a bit wet just to dry it off. But I think this is a success. A fix. Basically the cap was pulled up a little bit, and the reason for that I think is the twist in that big hose was trying to pull it one way or hold it one way, and so this way here now it's when it's full, and because when it's full it doesn't have as much give on the bag, right? And then as the bag deflates it gets softer, so then the hose can be kind of anywhere. So that's why that came off. I'm almost positive here now because it's not leaking. And it held a lot. That was the second thing I noticed. When I was trying to put the cap back on, I could never get it to, it didn't feel like it was grabbing tight. But then as soon as I got the inside section into the bag, like where the O-ring was all the way in, and then I put the cap on, the cap felt like it was grabbing better, the threads. So that's probably the indicator right there. My sail here, the wind just shifted, but looks like it's going to dry off pretty quick in this heat.